Hello, everyone, and welcome to this special episode of the Psychedelics Today podcast. This one is going to be me, Manesh Girn, aka the Psychedelic Scientist, with my good friend and colleague, Melanie Pincus. Hey,
Hello,
Melanie.
everyone. Hey.
We wanted to put together this episode to discuss some of the core topics in our course, Psychedelic Neuroscience Demystified, for which we're about to launch our second cohort on October 4th in collaboration with Psychedelics Today. So in this podcast, we're going to be talking about some of the content we cover in the course, but it also serves as an overview of some of the core topics in psychedelic neuroscience currently. And before we dive in, just a little introduction. I'll give one on myself, and then Melanie will go ahead with hers. So me, name is Manesh Girn, as I mentioned. I am about to start a postdoctoral research fellowship at the University of California, San Francisco, where I'll be working with Dr. Robin Carhart Harris doing brain imaging research related to psilocybin, among other things. And I'm a neuroscientist, so we're both neuroscientists, about to finish my PhD in 2 days, actually. And my interests are primarily in the neural mechanisms of psychedelics. So through what brain changes do they elicit the profound experiences that they elicit, and why and how can these lead to healing and transformation? And these are things I explore using a combination of brain imaging, but also psychological assessments and different cognitive tasks, and these kinds of things in humans. And that's, in essence, what I'll be doing moving forward. So, Melanie, I'll let you give an intro as well.
Hi, I'm Melanie Pincus. I have my PhD in neuroscience, and I started my PhD in 2011, and I was studying early life stress and trauma and how it affects the developing brain, in particular, these circuits connecting the prefrontal cortex with limbic structures that are really important for emotion regulation and get compromised in response to chronic stress, putting individuals at risk for developing mood disorders during the adolescent transition. And during my time in academia, I was coming across the really exciting research coming out around how effective psychedelics are for treating mood disorders. So there was a way in which I was becoming really interested in psychedelics for professional reasons, aligned with my interests in mood disorders. And then personally, too, I've always felt myself to be a seeker and interested in altered states of consciousness. And so when I finished my PhD, I was definitely on the burnt out side. I had to restart my dissertation actually from scratch in my fourth year and had different personal things going on too. So I decided that, when I was done with my postdoc and my time in academia, I was really ready and eager to go down to Peru and sit with ayahuasca. And it was the first time I'd ever had a more inward experience with psychedelics, and definitely had my mind blown by how intense the experience was and how fascinating it was. And one thing that really struck me was the strong individual differences in terms of the kinds of experiences I was having and the kinds of experiences I was seeing other people around me having. And it really drove home how personalized these medicines are. And I became really fascinated by these questions around what predicts the kind of experiences you're going to have in a psychedelic journey, both aspects of set and setting and neurobiological individual differences. And so even though I felt like I was done with my time in academia, I realized during my time in Peru, sitting with first ayahuasca and then other plant medicines, that I had all these really burning questions that I wanted to pursue. So I returned to the world of research, but on the industry side. So I've worked for some psychedelic startups, designing research programs for them, and I continue to be really interested in this question of individual differences. So
That was an awesome intro. I feel like I should provide some more biographical details as well. So me, how did I get into psychedelics? It was also through my own profound experiences. I'm not going to pretend that wasn't the case. And for me, it was quite early, around 17 years old, when I had an experience with psilocybin, with mushrooms, that really opened me up to seeing my life and myself in a different way. I just remember for the first time feeling like had separated from my sense of identity and my beliefs and my thoughts, and was able to see myself in life from a different vantage point that's more expansive and like wider and more panoramic. And I just remember being struck by how deeply our experience of the world can be changed with just a little bit of, a couple grams of mushrooms. And at the time, I remember, recalling how people would tell you that psilocybin and other psychedelics are harmful and dangerous and would make you go crazy. Yet I saw very firsthand how they could be a source of deep insight. And that inspired in me a deep curiosity for these kinds of things. And I remember reading Stanislav Grof, his book, it's LSD Doorway into the Numinous, and that really inspired me, just the depth and kind of meticulousness with which he approached describing these experiences and creating his own cartography of psychedelic states. And it just made me so fascinated, and also showed me how these kinds of things can be studied in a credible, scientifically grounded way, and also in kind of a nuanced fashion. And so I thought, wouldn't it be awesome to also be a psychedelic researcher? And I've basically organized my entire 20s towards that end, and I'm now living the dream of doing that. And I just find it so fascinating, and think there's so much potential for understanding more about how the brain constructs our reality, how our sense of self functions as a lens through which we perceive reality, and how these things can be changed in pursuit of healing, but also just personal transformation and greater abilities to thrive in healthy people. Um, so that's my journey into psychedelics and where I'm coming from.
Manesh, when you entered undergrad, did you know you were already like on a path to study psychedelics, and what was your undergraduate degree?
I was most interested in just understanding the mind and consciousness. And I originally wanted to be a psychology and philosophy double major. And then eventually I got into cognitive science. And so my degree was eventually a program called Cognitive Systems at the University of British Columbia in Vancouver, where it combined philosophy with computer science and psychology slash neuroscience and linguistics. This cool interdisciplinary program aimed at studying the mind. And I worked in a brain imaging lab, as you know, for like 4 years during that period too. Mm-hmm. Cool. So maybe next, let's switch gears. Let's like first briefly say why we created the course, our neuroscience course, and why we think neuroscience is important for people to learn. I could start. I mean, for my understanding, well, me and Melanie are good friends, and we thought of, what's a good way to bring our skills and background together. We've both been involved in disseminating knowledge in the space independently, and in observing the landscape of offerings, there was clearly no comprehensive neuroscience course. And you see it a lot in the media. There's a lot of articles about it. People talk about it a lot, talk about neuroplasticity, the default mode network, all these things, but there is no good course for non-neuroscientists to understand all of it. So we're like, what a great opportunity for us to put our brains together and create something that's engaging and accessible. Because ultimately, neuroscience really informs things like integration and also how people might make sense of their experiences. And so, and as you'll see throughout the rest of this podcast and also in our course, there's a lot of value for the practitioner as well as just psychonauts in understanding the neuroscience. I don't know if you have anything to add to that, Melanie.
Yeah, sure. I would add that these terms get thrown around in the media, like neuroplasticity and the disintegration of the default mode network, but I think it's hard for people to really appreciate what that actually entails and what relevance it has for the therapeutic benefits of psychedelics without really understanding just basic foundational knowledge of how the brain is organized, how it works, and how it's altered in different mood disorders. And in the first cohort of our class, we had a bunch of doctors and nurse practitioners and different folks in the medical field. And a lot of them were there because they were getting questions from their patients around psychedelics and wanting to understand their healing benefits. And so these doctors and nurses really wanted to understand at a deeper level um, how psychedelics are acting on the brain to produce therapeutic benefits. And so they definitely appreciated having a comprehensive understanding that we offer in the course by contextualizing these mechanisms of action in a broader understanding of neuroscience itself.
Hmm. Totally. And Melanie, is there anything you could say about major lessons you've learned from your own psychedelic journeys, like and or how your neuroscientific understanding has impacted that?
Yeah, I've been thinking about this a lot lately, and I was just talking about it at Burning Man with somebody. So I think for me, what's really interesting about psychedelics is they offer this like real time feedback for me to really stop struggling against the way things are and just really open myself up. And it's so hard to articulate exactly like what that means and what that looks like. I mean, I think some of it is more of a tangible thing, like my muscles aren't bracing as much and I'm like literally relaxing more, but it also feels pretty energetic. And for me, my experiences are highly somatic. So um, for anyone who's like ever gone to physical therapy and experienced the TENS unit where like the electricity is coursing through an injured part of your body, I feel like my psychedelic experiences are often like I'm this tuning fork and like these different electrical currents of different frequencies are coursing through me all at the same time. And it's like pretty uncomfortable until I like completely stop resisting it and just fully allow it. And the more I resist it, the more uncomfortable it becomes. And then, like, as I stop resisting it and like open to it and just fully allow it to be what it is, then the experience becomes a lot more easeful. So, in this very powerful way of it giving me this like real time experience of like how much extra suffering I'm creating by resisting an experience, it really helps me open up. And then I notice that in the period after a psychedelic experience for weeks or even months, sometimes like it just generalizes over to me feeling just more open and more willing to go with the flow of life. So that's been one uh, consistent learning for me from psychedelics. And then I also would say that I've never really had a full mystical experience or an experience of ego dissolution. And I don't, it's not that I think that that's like absolutely necessary in some way, because I think there's a lot of learnings from these substances, including a lot of emotional catharsis that you can get benefit from, and, and lots of other insights and things like this. But I also do think it would be like nice to experience that unitive type of experience that people have commonly with psychedelics. And so I look to the neuroscience and psychology research around the individual differences question of what predicts people having more easeful entry into mystical experiences versus more blockages against entering into those states, to really understand my own potential blockages with that. So, for example, there was a study that found that individuals with a lower diversity of executive network nodes at baseline had stronger experiences of ego dissolution. And this is a bit complex, but basically, having a lower diversity of network nodes means that that executive network, which is really important for lots of high level things like planning, executing goal oriented behaviors, and things like this, it's efficiently segregated from other networks, and this is interpreted as having firm ego boundaries. And the authors of this study interpreted that as maybe these individuals are more sensitive to the ego dissolving effects of psilocybin. That was the substance being used. And my takeaway when I thought about it was like, wow, there's a lot of wisdom traditions that posit that before one can transcend the ego and access these higher states of consciousness, they have to have a well integrated and healthy ego. So I wonder if that might be what's going on, that having a really well defined ego boundary is actually really serving you in the psychedelic experience. And that when I think about my experiences, like maybe there's a way in which my attachment style, which is disorganized, um, you know, doesn't lend itself to having these like efficiently segregated networks in my mind. And that creates these more difficult challenges to enter mystical states. So I'm still gathering information, but as I really feel like research is me search, and as I like try to unpack what's going on for me, I also think about how it generalizes to everyone else out there. So that was a lot, and I'm really curious what you have to say on the matter of what your some of your main lessons from your psychedelic journeys are and how your knowledge of neuroscience impacts that.
Totally. Yeah. Thanks for that. Yeah. Research is me search. I love that. I haven't heard that before.
You haven't heard that?
Um, no, no.
Wow.
Yeah. So for me, kind of similar in certain respects, I think a major insight from my psychedelic journeys is just how dense and heavy like thoughts and mental content can be. And we, often feel the need to overanalyze and think about things
Mhm.
and get lost in our concepts and internal dialogue as opposed to experiencing things in the moment as they are, in a more deeper kind of intimate way, having a greater intimate relationship with our senses, with the immediacy of what's happening. And my psychedelic experiences, with whether it's with psilocybin or 5-MeO DMT or what have you, have allowed me to glimpse into states where that stuff is just totally removed, and I'm just immersed in the rawness of experience, and just how beautifully vibrant and alive and spontaneously intelligent that is, and how superfluous a lot of our thinking really is, and it just weighs us down, you know and and so I think my journeys have just allowed me to live with greater ease and hold on to my identity and my narratives much more lightly. So I see them, I acknowledge them, but I'm not totally lost in them. I don't identify strongly with them a lot of the time. And this actually goes hand in hand with the concept of psychological flexibility, which we talk about in the course and which is talked
Mhm.
about a lot in psychedelics. Because core parts of psychological flexibility are this something called cognitive diffusion and self as context, where cognitive diffusion is like you're defusing, you're not being fused with your cognitive content, so you're thinking. And so you're able to step back from your thoughts and acknowledge them, be aware of them without taking them at face value and reacting to them immediately. And then self as context is realizing yourself is the lens through which you see the world. It's not intrinsically you, it's just a filter that you have on your experience. And being able to separate yourself from your sense of self and its filter, realizing it's just one way of viewing things out of many. And I think psychedelics have definitely contributed that to my life, and allowed me to live with much more ease and flow, and just spaciousness and internal spaciousness. Um,
Would you say
and
cognitive
yes,
diffusion is like a type of psychological distancing?
yeah, I think it's synonymous with psychological distance in some sense. Yeah, yeah, totally. And how does my knowledge of neuroscience impact on this? Um, for me, it's more about, it's almost like a sense of grounding in that right now, my sense of who I am and what the world is has been kind of thrown in some kind of disarray, and it's no longer solid. And it's recognizing that this is very likely due to disruptions in neuronal populations that usually encode these beliefs, and whether they're in the default mode network or elsewhere. And that in that opportunity is such a um, great opportunity to refine or change those beliefs. It's like by breaking things up and inducing a kind of temporary chaos, you can create a new order. And I think the kind of concepts of neuroscience serve as guiding I guess metaphors at the end of the day to try to um, allow me to better recognize the potential of that experience and where I can take it, and also give me a sense of grounding. Like I don't need to be fearful. It's just a transient disruption of neuronal populations due to serotonin 2A activation and the hyperexcitability of neuron populations and entropy and etc. All the things we talk about in the course. And yeah, so I think a sense of grounding and meaning making. At
Mhm.
the end of the day. But also, when I'm in a psychedelic experience, I turn off my scientific brain and I'm just there as a human. Because I think the scientific brain is very cognitive and heady. And I think the richness of the psychedelic experience is when you get out of your head, into your body, into your senses. And so, yeah, it's usually after the fact when I'm reflecting that I bring in the neuroscience.
Mhm. That makes perfect sense. Same. Though I will say I still am working with my monkey mind during my psychedelic experiences, but what has shifted for me, and I thought about this when I mentioned the psychological distancing, is there is this way in which I can see my monkey mind and have a lot more compassion for it. And that's also a well-known phenomenon with psychedelics and MDMA, is that they have these empathogenic qualities to them. So I feel like during a psychedelic journey, when I see my mind getting very active and wanting to understand and deconstruct what's happening, I'm able to relate to it way more empathically. And then I think that that also facilitates it stepping back more easily. So, Manesh, let's start diving into some of the content from our course. And I wanted to start by asking you, how is psychedelic therapy different from standard drug treatments?
Yeah, there are a variety of differences, right? So I think a core one is that psychedelic therapy is essentially an experiential mode of treatment. It's based on the profound and radical and potentially transformative experiences that psychedelics can induce. And if you compare that with standard drugs, for example, like SSRIs, you take them, every day for a period of time, and behind the scenes, they modulate your brain chemistry to support, less negative moods, essentially. And so, rather than relying on this behind the scenes thing, which doesn't involve your active engagement, psychedelics require you to face what's going on in your mind, maybe face some difficult emotions and memories, things you had been avoiding, and facilitates your ability to potentially process them and see things in a new light and release pent up energy in your nervous system and all of these things. So I think a core thing with psychedelics is they involve your active engagement in relation to making sense of and integrating a profound experience that could be a source of psychological insight, emotional catharsis, and spiritual connection, and all of these things. And importantly, they don't rely on chronic use and dependence. You're not going to be expected to psychedelically trip every day. Probably can't because the tolerance will build up anyway. But and you don't have the chronic, lasting side effects that come with standard drug treatments as well. The main quote unquote side effect from psilocybin, let's say, is having a delayed headache, having a headache the next day, and maybe being a bit more tired, and maybe being a bit sensitive to your emotions for a few days. Which that last one, could be seen as like an emotional side effect, but if anything, it can help you process things if you're well supported. Whereas with things like SSRIs, you'll get like maybe, your sex drive will be killed. You can gain some weight. Your ability to experience extreme emotions, good or bad, is gone lower, and might have sleep issues and all these things that you just don't have with psychedelics.
Yeah, I was just gonna say, I think you touched on this, but I just wanted to emphasize too that what has jumped out at me from the literature is this theme of the experiential avoidance versus like emotional engagement, whereas the psychedelics really seem to facilitate people engaging with difficult emotions and then having emotional breakthroughs as a result of that. These patients who participated in these studies have contrasted it with their previous treatments with antidepressants, where they feel like the antidepressants really blunted their emotional experiences and therefore, in ways, reinforced their avoidance of dealing with difficult emotions.
Totally. And I know you talk about this a bit in the course. Maybe this is a good spot where you can give a little sampler of some of the brain imaging findings there.
Sure. Yeah, this is one of the interesting facets of psychedelics is that they really allow people to engage with difficult content, both like personal material that's current and also like old material, and including sometimes repressed emotional material. And neuroimaging studies that have been done while people are in the acute experience and are seeing emotionally laden stimuli in the form of different faces. So, angry faces, sad faces, and neutral faces and positive faces. What they consistently find is that the amygdala, which is a well known region of the brain that really responds to aversive stimuli and also emotionally salient stimuli, it is less reactive under the influence of these drugs. And that's also particularly interesting because when we look at mood disorders, we tend to see that this region is hyperactive and in response to emotional stimuli. So it seems to be that perhaps what's happening here is that these drugs, and this includes the classic psychedelics or serotonergic psychedelics and MDMA and ketamine, is that they're turning down the dial on this brain region that's can be hyperreactive in mood disorders, and that perhaps that is really helping facilitate engagement with these difficult emotions that can come up and difficult memories that come up for people.
Awesome. Thank you for that. I'm not sure if you mentioned it, but you're talking about the amygdala, right? Which a lot of people may have heard of, which is involved in fear processing and kind of being vigilant for threats.
Yes, I did mention that.
Oh, you did. Sorry. And is there anything else you can add about the differences in neural mechanisms between psychedelics and, let's say, SSRIs?
Yeah, so um, what I would say is starting out with thinking about the differences in the way that they interact with the serotonergic system. So, this is pretty common knowledge out there that the SSRIs, they will work by blocking the serotonin reuptake inhibitor. And so that increases serotonin in the synaptic space. And the idea is that with more serotonin available, it will bind to the serotonin 1A receptor. And this receptor is known for its role in passive coping in response to challenging experiences and stressors. So, what this means in terms of passive coping is that it will enhance one's patience and reduce aggression, reduce impulsivity. So, it basically helps you deal with a difficult circumstance by chilling you out. And by contrast, the serotonergic psychedelics, which includes things like LSD, psilocybin, DMT, ayahuasca, 5-MeO DMT. These substances, they are analogs of serotonin, and they bind to the serotonin 2A receptor. And this receptor, it has a lower affinity to serotonin. So in a regular brain at baseline levels, serotonin is going to preferentially bind to 1A. But when you now introduce this serotonergic psychedelic and at a high enough quantity, it's now going to bind to the serotonin 2A receptor. And in contrast to the passive coping of the serotonin 1A receptor, the serotonin 2A receptor is well known for its role in active coping. So it promotes learning and neuroplastic changes. And the idea is that when a stressor is really extreme, binding to the 2A receptor will allow an individual to cope with this really difficult circumstance by finding novel solutions to deal with the current challenges on hand. And so the ways in which the serotonergic psychedelics bind to the serotonin 2A receptor seem to play a really important role in how these drugs are robust at promoting neuroplasticity in the brain. And that kind of parlays also into the second point I wanted to make about their differences in terms of neuroplasticity. They both are known to promote neuroplasticity, the SSRI class of antidepressants and serotonergic psychedelics, as well as ketamine and MDMA. But they haven't been directly compared. However, a new study that came out a few months ago, I think, that looked at the um, binding to the TrkB receptor, which is the receptor for the brain-derived neurotrophin factor, BDNF, which is a protein that is extremely important for neuroplasticity in the brain. It's kind of like the endpoint of a lot of signaling pathways that will turn on neuroplasticity in the brain. And its receptor, TrkB, will initiate signaling pathways that turn on neuroplasticity. And so, what this research study found is that psychedelics bind directly to this TrkB receptor, and the affinity of the psychedelics to the TrkB receptor are 1,000 times higher than those of the current class of antidepressants. So, this is a really striking difference and might explain how these psychedelics are both rapid acting and really robust at promoting neuroplasticity compared to antidepressants.
Awesome. Thank you for that. What a great answer. So maybe this is a spot where I can jump in and just describe some basics on what neuroplasticity is. And there was also another really cool finding published in Nature recently about critical periods, which is very relevant here as well. So first of all, it's like, what is neuroplasticity? And a basic definition is that it's the ability for neurons, aka brain cells, to create new connections with each other or rewire/change existing ones. So essentially, it refers to the ability of the brain to mold itself and change in responses to experiences, when we learn something new, when we need to recover from an injury, and other contexts. And we now know that the brain is neuroplastic throughout the lifespan. It's the most plastic in early childhood, but whereas previously it was thought that the brain at some point in time stops being plastic, it's now known that neuroplasticity is preserved throughout the lifespan, although less in older age. And as Melanie was kind of mentioning, psychedelics are known to boost neuroplasticity. And there are a variety of findings now, mostly in rodent studies, because it's easier to study this in rodents, indicating that psychedelics boost neuroplasticity. And in our course, we go into detail on what exactly that means. What does it mean to boost neuroplasticity? And just as like a little teaser, what it means is essentially it's increasing the complexity of the part of a neuron called its dendrites, which are basically the receiving stations for a neuron to connect with other neurons. And it's making these dendrites more complex and larger so that more connections can be formed between neurons with various consequences. Very relevant for integration as well. And I mentioned critical periods, so this comes in here as nicely as well. So a critical period is a period during brain development where a certain part of the brain is hypersensitive to a certain type of stimuli, to certain types of information, and essentially needs that information in order for that brain region to properly develop. And an example is in the visual system. There were some experiments conducted, I think in the 80s, possibly, maybe before that, which one ended up leading the researchers to win the Nobel Prize. And but there were kind of ethically questionable studies that they did on cats. In one of these studies, for example, they had newborn kittens and put them in a box where they can only ever see vertical lines. So they never saw anything horizontal. And they did this for the first, I think, weeks or so of the kittens' lives. And when they took them out of these boxes, they were just unable to see horizontal lines. They could only see the stimuli they were exposed to in their early development. And no matter how many horizontal lines they saw after that, they just couldn't develop the capacity to see them the way they were able to see vertical lines. And so they would just walk into anything, like any kind of flat surface or table that was horizontally shown to them. And that's evidence that the brain has a critical period for the visual system where it's being taught what kinds of things it's able to perceive. And so it really, the development of the visual system really heavily depends on seeing the kind of stimuli it's going to expect over the rest of the life. And so there are a variety of critical periods like this in the brain. And essentially, a critical period is a period of hyperplasticity and of greater plasticity than usual. And so in these studies done in the lab of Gul Dolan at Johns Hopkins University, published in Nature recently, they found some findings related to social reward learning critical periods. And Melanie and I actually just released a blog post on this for Psychedelics Today as well. You could probably find if you just Google search that, or on the Psychedelics Today website. And essentially what this involves is having rodents, putting them in this cage that has two rooms, where one room they're able to hang out with friends and like other rodents and have positive social interactions, and the other one where they're always alone. And when they're early in development, if you expose a rodent to those two types of interaction, or like no interaction with others, interaction with others, and then put them in that cage when there's no other rodents in there, they'll just tend to hang out in the side where they had positive social interactions longer. They have what's called a conditioned place preference. They're conditioned to prefer that room based on positive social interactions. That they're there, they're in there because they're seeking out those interactions again. But as the rodent gets older, their ability to learn that association with that social room goes down. So it's kind of like if they had positive or negative social interactions during that period early in development, it will then determine whether they naturally gravitate towards environments that they associate with social interactions. And so this seems to go away after, I forget the exact numbers, but something like 7 weeks after being born. But if you give them a psychedelic, whether that's MDMA, ketamine, psilocybin, LSD, or ibogaine, it seems to then open that critical period again. So they're able to relearn the social associations. They're able to learn to prefer that social side of the cage, when before it was now past that period where they're able to do that. And so that's pretty striking. That means in this specific context, it seems to open plasticity in a way that was only available when they're really young, and says a lot about how positive social learning might play a role in the therapeutic effects of psychedelics. So that's a particularly cool example of increased neuroplasticity.
I wanted to contextualize that too. This critical period that we're talking about right now with this paper that just came out of Goldolan's lab is a critical period during adolescence. And although a lot of critical periods happen very early on in life, adolescence is also recognized as a critical period. And it really helps reorganize the brain to support things like increased exploration, risk taking, and social behavior across a number of species. So it's like extremely important for individuals during this adolescent period to start becoming very interested in their peer group, and the changes that happen in the brain help support that. And there's also a lot of like interesting therapeutic relevance to these findings because there are aberrations with processing social reward in across many different um, mood disorders, and so like there's ways in which also people are really sensitive to social rejection, and they don't find social interactions as rewarding, where the aversive qualities outweigh the rewarding qualities. So these results really speak to exciting potential for these substances to play in a really important role therapeutically to ameliorate any kind of long lasting changes that happened during that adolescent critical period where people didn't experience secure attachments to their peer group.
Mm-hmm. Awesome. And maybe this is a transition into talking about one of the ways neuroplasticity can go bad in the brain. And this is very relevant for mood disorders and depression and so on. We know that chronic stress is basically the silent killer in developed societies today. And it has a pretty strong impact on neuroplasticity and can lead to the generation of mood disorders. So, Melanie, I know this is stuff this is in your wheelhouse. So, do you want to
Totally.
talk about that a little bit?
Yeah. So at the top of the hour, I talked a bit about my dissertation work where I was focusing on emotion regulation circuits. And so that is largely connections from the prefrontal cortex down to limbic circuits, limbic areas, including the amygdala and the hippocampus. And these two regions are really important because we've been mentioning the amygdala a few times, but I also wanted to point out that the amygdala has direct connections to turning on the hypothalamic pituitary adrenal stress response. And its counterpart, the hippocampus, can actually turn off that stress response. So the prefrontal cortex, this very newer evolved region, is extremely important in playing this high level role of having top down control of the hippocampus and the amygdala, with then repercussions for whether the stress axis gets turned on or turned off. And so what we see really consistently in the literature is that chronic stress in animal models will cause atrophying of the synaptic connections in the prefrontal cortex and in the hippocampus. And so now we have this situation where the prefrontal cortex is impaired in its ability to both regulate the amygdala. So then what happens, it turns out, is that the amygdala is really reactive, and it's not getting silenced and quieted by the mature prefrontal cortex. And also it compromises the connections between the prefrontal cortex and hippocampus, so that the hippocampus is now less able to do its job of turning off the stress axis. So what that ends up kind of feeding forward into is these kinds of cognitive biases that we see in mood disorders. So across many different disorders, we see that there's the dial is turned up on negative valence and turned down on positive valence. And so across many domains, including attention and memory and decision making, individuals are showing, for example, an attentional preference for negative stimuli and biases away from positive stimuli. They're making decisions that are heavily weighted by the negative stimuli they're encountering and underweighted by positive experiences and stimuli they're encountering. And then with the loss of synaptic connections between the prefrontal cortex and these limbic structures, these biases become more and more entrenched, and it becomes more difficult to escape these ways of experiencing life when you're really in the grips of a mood disorder, which really sets the stage for how important psychedelics are therapeutically because of how robust they are at promoting neuroplasticity in the brain.
Awesome. Thank you for that. And I think another important piece here is the length of these neuroplastic changes. How long do they last? And we have some research talking, indicating how long it might be. And in relation to critical periods, the research from Gul Dolan's lab that we mentioned suggests that with psilocybin and MDMA, that critical period for social learning, at least in rodents, it's an open question to what extent this translates to humans, that it stays open for about 2 weeks. So within that 2 week period, if we assume it translates into humans, you're more able to learn new fundamental ways of understanding social relationships, and potentially, whereas before you have an innate tendency to avoid them due to anxiety or fear or past negative experiences, especially in early childhood, you might have a strong ability to relearn more positive associations, depending on the nature of the interactions you have in that 2 week period. And this really highlights potentially the importance of the guide, the therapist, and something called the therapeutic alliance, which is basically how close and connected you feel with your therapist and how much you trust them, and you're able to kind of work with them towards a shared vision of you getting better. And this really highlights the interpersonal component of therapy in general, and particularly psychedelic assisted psychotherapy, and in learning these new ways of socially relating and perceiving social relationships. And then neuroplasticity more generally, let's say outside of the specific context of critical periods, the research loosely suggests that the period from around 6 hours to 72 hours after your experience might be the most neuroplastic. It's a period where you have the highest increase in number of new synapses, new connections between neurons, and new, or this, you could think of it as larger, more complex dendrites. So more of an ability for that neuron to receive inputs from a greater variety of other neurons. And and for integration, this suggests that especially the first 3 days or so after an experience, your brain is more malleable in a lot of ways than it usually is. So this is very important to be conscious and intentional about what behaviors you're engaging in, how you're thinking about things, what thoughts you're endorsing to yourself, in addition to who you're relating to and who you're around. And again, really emphasizes the point that psychedelics don't do the work for you. They're giving you this neuroplasticity, but how that's going to be turned into lasting new connections really depends on what you're doing after in those 3 days. But also much longer, because your studies finding that even 30 days later, some of those neuroplastic changes are persisting in rodents. And presumably in humans, the ones that persist are the ones you're continually activating afterwards. So like consistent, conscious, intentional action towards the person you want to become, or in alignment with the insights from your experience, are super important for having lasting benefits from psychedelics.
Thanks, Manesh. Yeah, I wanted to add a little bit more information too, and point of clarification. So the critical period that we were talking about with adolescence being reopened by psychedelics, the plasticity changes we're seeing there are in a region of the brain called the nucleus accumbens, which is a reward region of the brain. And then outside of that, generally speaking, there's also abundant research showing that psychedelics increase plasticity in the prefrontal cortex and hippocampus, the regions I was mentioning just before, that are really important for emotion regulation. And as Manesh mentioned, it seems like the peak period of that is happening in the first 72 hours of after taking a psychedelic, but that it continues to endure and be higher than baseline levels of neuroplasticity for another month. So that it's really important to be aware of that, be really discerning around how you want to be spending your time, what you want to be taking into your consciousness during that period of time. And because the prefrontal cortex and hippocampus are so important for emotion regulation, and we know they're in this hyperplastic state after a psychedelic experience, it also would be really beneficial to practice particular techniques that really strengthen that muscle of emotion regulation. And there's plenty of options out there, including breath work, meditation, these sorts of practices. Manesh, I know that your PhD work has focused on the default mode network, and there's a lot of discussion in the psychedelic space around the importance of the default mode network for psychedelic experiences, in particular experiences of mystical states and ego dissolution. And I've heard you really eloquently explain that it's a lot more complex than some of these sound bites will suggest. So I'm really hoping you can unpack that for us a little bit right now.
Yeah, definitely. So the story between psychedelics and the default mode network is a bit complex, as is everything between the psychedelics and the brain. But so just to start off from the basics here, the default mode network is this network of brain regions which are quite interconnected and involved in a lot of shared functions. And what's interesting about the default mode network is that it comprises the parts of the brain that are most expanded in humans relative to other primates. And this includes parts of the prefrontal cortex, but also regions in the parietal lobes as well as the temporal lobes. And in essence, the default mode network regions are involved in things like our ability to remember past experiences and imagine the future, to reason and think about the mental states of other people, to create our own internal self narrative and process self related information, and also basically use information, like use memory information to interpret and understand the external world, and whether it's watching movies or listening to narratives or just understanding our experiences. And so it's involved in a lot of these very complex aspects of our thinking, and many of which are unique to humans. Hence, it's because these regions are more advanced and developed in humans in particular. And there's a lot of talk in the psychedelic space of how the DMN, the default mode network, might be most important for psychedelic effects. And that claim originates based on a 2012 paper by Dr. Robin Carhart-Harris and colleagues looking at psilocybin, and they found that one of the main effects of psilocybin was to decrease activity in the default mode network, and that this was actually also correlated with ego dissolution, which at face value makes a lot of sense. It's essentially, and this is a narrative, it's turning off, quote unquote, no brain regions ever turned off, by the way, but it reduces the activity of or disintegrates this part of the brain that's related to our sense of self. And so it makes a lot of sense that that's related to that in the psychedelic experience. But there are several complications here. One, not every study has found that. There's been several studies which straight up did not find a correlation between the default mode network and ego dissolution. Moreover, psychedelics do disintegrate, reduce the integration of the default mode network, but they also reduce the integration of nearly every network in the brain, and many of which more than the default mode network. So based on the brain alone, there's nothing that suggests necessarily that the default mode network is most important. There's a lot of inferences being made on it, but not directly based on the data. If that makes sense. And so the picture between default mode network and ego dissolution is complex because why isn't every study finding it? And what I think and what other researchers think is because ego dissolution is a very complex experience. And one distinction that's been introduced into literature is a distinction between the minimal or embodied self and our narrative or autobiographical self, and how these might relate to ego dissolution. So the minimal / embodied self, I'm just going to call it the embodied self, corresponds to our basic sense of being located in a body that has a particular first person perspective on the world. So it's very much involved with I am this body, I am where my skin ends, I'm seeing the world through my eyes, and I feel like I'm located in my head. We all feel like we're located there because that's where our eyes are, and our visual modality is our primary way of navigating the world as humans. And so there's that one type of self. And then the other self, the narrative / autobiographical self, is rooted in our narratives, our concepts and stories about who we are, our traits, our past, our future, our identity, as can be conveyed in language and concepts. And the idea is this embodied self is like more basic and fundamental, and humans, given our advanced cognitive abilities, are able to construct this narrative autobiographical self on the scaffolding of that embodied self. And if we try to link this to the default mode network, it would make a lot more sense that the default mode network is specifically related to our narrative autobiographical self, right? Because it's involved in concepts and memories and these kinds of things. And that our embodied self is probably more located in regions of the brain related to our sense of having a body, being located somewhere in space. And what's interesting is this is kind of supported by the research. So whereas some findings have suggested, the default mode network is correlated with ego dissolution, other studies have found that other regions which are involved in the embodied self are correlated with ego dissolution. So this includes the temporoparietal junction and the insula. So the temporoparietal junction, aka TPJ, is interesting because if you zap this region with magnetic stimulation, it can induce out-of-body experiences. So literally, that region of the brain, which is in our parietal lobe, is involved in integrating our sense of touch, so our somatosensory functions, with our visual perception. And so you think of touch and vision coming together to create a sense of where you are in space in this body. And the insula is involved in connecting our brain to our autonomic nervous system and our body. And so that's very much our sense of embodiment. And so it seems that ego dissolution comprises two main components, potentially one related to the insula and TPJ, related to our body, and then the other one, autobiographical self, related potentially more to our DMN. And current, really quick before you ask me something, Melanie, ways we measure ego dissolution don't make that distinction. So we're conflating these two very different things together and looking at one correlation. And this is why the findings are probably inconsistent. And so we need more refined psychological measures that we can then link to the brain, but they haven't been published in literature yet.
Are people developing those instruments right now to separate out those two different components of the more body-based versus the more memory-based versions of self?
You know what? I've been wanting to do that for a while. I'm just too busy doing too many things. But I remember reading, I don't remember who was developing it, but I remember somebody proposing it. I feel like it might be Chris Lethaby, who's a psychedelic philosopher in Australia.
Mm.
I think him and others, because I've talked to him about this too, and I know he's on the same page. I think him and others were proposing a new measure of ego dissolution that specifically accounts for this philosophical distinction. And we definitely need
And
it.
then if there is a distinction between the two, do you think that you could just as likely have dissolution of one or the other? Or the way you were presenting it before, where it's almost like the memory version of self is resting on the scaffolding of the body version of self, the minimal embodied self, it would you not get to the dissolution of embodied self unless you had enough dissolution of the memory-based version of self?
Yeah, it's a really interesting question. And at the end of the day, it's an empirical question. It has to depend on what the data tells us, right? And I think in principle, it's possible that they could be distinct. You can lose all sense of who you are and your identity, but still feel like you're in this body. Or maybe you feel like you have no body, but you're thinking in your usual identity.
Mhm,
Like in principle, that's possible, right?
mhm.
Then the question is, which one is ego dissolution? Is it when both happens? Is it
Mm,
when the narrative goes
mhm,
away? Is it
mhm.
when we don't have a body? And this just points to the limitations of the construct of ego dissolution. It needs to be more refined. Yeah, it's all super interesting stuff.
Do you think that this is a controversial question. Do you think that the pacing at which these instruments are coming into being and, like, that this hasn't come into existence yet, this distinction is a consequence of psychedelic researchers themselves not being that well versed in psychedelics and having like their own
Yeah,
deep experiences.
it's interesting. It could very well be the case that that it's just people are running away with the abstract concepts and not clear on what the actual phenomenology might be
Mhm,
like,
mhm.
and not putting enough emphasis on qualitative, measures and interviews of what people are actually going through when they're not constrained by a given questionnaire. And I think another aspect of this might be a lack of engagement with the existing literature on the sense of self in philosophy and cognitive
Mhm,
science.
mhm.
So I think if you're fully aware of that, then this kind of distinction is so obvious to look at. But yeah, there needs to be more interdisciplinary integration for
Yeah,
sure.
totally. I feel like ever since I started in my PhD, there's been a lot of lip service paid to the need for more collaboration and conversation between the philosophers and the neuroscientists, and I still like hardly ever see evidence of that.
Yeah, totally. And actually, I just want to plug a paper that I recently published with our good friend Sharday Mazarnjan, which is critiquing the concept of mystical experiences, which go hand in hand with ego dissolution, and highlighting new ways of understanding it that's more interdisciplinary, because a lot of these things have a large history of scholarly study in the humanities. And I think the humanities and the concept and the conceptual distinctions introduced there can really help inform the creation of quantitative
Mhm,
assessments and inform the kind of level of sophistication in our conceptual frameworks in neuroscience as well.
mhm.
So everyone should check out our paper. Oh, what is it called? I'm forgetting the name. It's about, you could search my name and mystical experiences and you'll find it.
Cool. Thank you so much for that really thorough answer.
So another really interesting topic in psychedelic research is how psychedelics can affect our processing of memory. And this is particularly important, for example, for stuff like PTSD, where removing the strong, overwhelming emotional charge from memories and changing your relationship to existing memories is a major theme, right? Is there anything you can say about research on how psychedelics may help us re-encode our memories differently?
Sure. So a lot of this research is based on MDMA's usage for treating PTSD. So I want to first contextualize it by talking about PTSD for a moment and saying that I'm sure a lot of people are familiar with this disorder and that it's characterized by persistent, intrusive memories. And what we see with PTSD is that there's deficits in fear extinction. And what this means is that when we learn an association between a cue and something that hurts us, causes us bodily harm, we learn this fear memory. And it's like in animal models, what we do to simulate this experience is we present a tone and then we pair it with a foot shock. And very quickly, a mouse or a rat will learn to associate that tone with the impending foot shock. And so they'll respond by cowering and being in a state of fear at the impending foot shock. And this is a really robust and durable way of learning because we need to learn really quickly to avoid things that cause us physical harm in our environment. And when that threat is no longer present, we also need to flexibly learn that that cue, that predicted foot shock for the animal, say, is no longer a is no longer a salient piece of information that's going to present us with threat. And so we also now need to learn that that's a safe um, cue. So, for example, in the real world, if you're a soldier in a wartime experience, you might very quickly learn that certain sounds of a helicopter blade is very suggestive that you're in a dangerous environment. And then when you're no longer on the battlefield and you're at home and there's a helicopter that passes by because it's on the way to go to a hospital, the adaptive response would be to slowly learn that, like, okay, I'm in a safe place now, and that helicopter sound no longer is going to signify that I'm in a dangerous situation. But with PTSD, that fear memory association is still really durable, and there's a deficit in learning to extinguish this fear. And there are correlates in the brain of where this is happening, in particular in the amygdala, the region that we have talked about a lot. So there's a certain nuclei in the amygdala that receives information about the cue, so the tone, for example, with the mouse, and the foot shock, and it learns to pair those and then activate a stress response. And then when you're in the extinction learning phase and you're now presented with the cue and it no longer is paired with the physical shock, the prefrontal cortex, and in a particular region of the prefrontal cortex, the ventromedial prefrontal cortex, then it steps in and it inhibits that nuclei in the amygdala from activating the stress response. So it overrides that original fear memory. And so this is called fear extinction learning. And in 2 different studies with mice, it was discovered that MDMA, when used in conjunction with extinction training, facilitated the learning of this, this the fact that it's no longer an unsafe cue, so that the animal stopped responding to the tone as being threatening. And when they looked under the hood, they found that evidence suggested that what's happening is that MDMA is binding the serotonin 2A receptor in the amygdala, and that this is thought to release BDNF, the protein we've talked about as being really important for neuroplasticity, and therefore facilitating neuroplastic changes that allow this new inhibitory memory trace to override the original fear memory. And so this was replicated in 2 different studies with mice and is super exciting. And MAPS is currently studying whether MDMA in combination with exposure therapy is going to be effective for PTSD, because exposure therapy is really analogous to this extinction learning, where you're exposed repeatedly to a cue that you previously thought signaled unsafety, but actually is now safe. And so it will be really interesting to see whether these studies are really effective, and maybe even more so in resolving PTSD symptoms than MDMA in combination with traditional uh, psychedelic therapy. So that's one fear memory process. And then the other one, which I find really fascinating, is the process of memory reconsolidation. And this is a modification of the original trauma memory. So uh, memories are not stable, and when they are reactivated, they enter this destabilized state where they can be modified and updated. And so this is what's known as memory reconsolidation. And it's believed that in PTSD, what happens is, because there's the intrusive memories over and over again, the process of reconsolidation happens over and over again. But what happens is the memory gets destabilized and then reconsolidated with the same emotional associations, which reinforces the traumatic narrative. And so it calcifies that memory. And what seems to be the case with this was from an animal study with rats, is that they put the rats through the paradigm of learning the association of a tone with a foot shock, and then they 48 hours later, they administered MDMA to the rats and then presented just the tone to them. So, this cue that had been associated with the foot shock. And then tested them a period later, like a week later. And what they found was that now the rats were showing a lot less fear in response to that cue. There was no extinction training or anything like this. So it was just the fact that when the MDMA was brought online, when the memory and the association with that cue was made active again, that it actually interfered with the reconsolidation process and softened that association so that it was no longer as triggering for the rats. And when we translate this to humans, the idea is that perhaps what's happening is that MDMA induces this super positive mood where you feel really socially connected, really empathogenic with your therapist or whoever is around you. You feel so safe and supported. And so, if challenging traumatic memories come up, there's this mismatch between the emotional trace of the traumatic memory and the unique state you're in with the MDMA on board. And so, this mismatch drives the memory reconsolidation process so that your traumatic memory is amended with less fear to be more in line with your current way you're feeling of being so safe and supported. So this was like the healing alternative to what typically happens in PTSD, where if the memory is reactivated, it's reconsolidated and calcified with the same old emotional associations. I do want to add, though, to this section that a colleague of ours, Manesh Girn, has talked about how with psychedelics, there is also the potential for false memories to arise. So there's been some research wherein participants are shown a list of words or other items to remember. And then after a psychedelic experience, they are then shown the list interspersed with like new words that weren't on the list. And they have to recall or report whether the items they're seeing are ones that they saw previously or are new items. And what they find with this research is that these psychedelics impair the recollection of items seen, but they enhance the sense of familiarity. And so this is kind of a little bit of like a dangerous combination, because when you can't really recall the details of something, but you have a strong sense of familiarity, this lends itself to experiences of deja vu and also false memories. So the fact that these psychedelics seem to facilitate this combination of like difficulty recalling particular details of past memories, but also an enhanced familiarity, suggests that there is the potential for false memories to emerge. And I think Manoj has talked about too that the ways in which psychedelics, especially the serotonergic psychedelics, really enhance imagery in the mind's eye can also add to this effect where a memory arising seems very real, seems very familiar, even if it didn't necessarily happen. So this is definitely like a controversial area because psychedelics have been well known for facilitating repressed emotions and repressed memories to come up. So there's a lot of questions around whether there's a potential for some of that material to be false memories.
Awesome. Thank you so much for that super thorough and detailed answer. So much information that, but such an important topic and exciting one and central to the therapeutic effects. And being mindful of time, let's wrap this up. This has been a great chat, and we've covered a lot of cool material here. And all of this is discussed in more detail in our course, which again is called Psychedelic Neuroscience Demystified. And you can find out more about it at the psychedelicEducationCenter.com. Our next cohort starts on October 4th, and it's an 8-week course. We have pre-recorded lectures, one from me, one from Melanie for each week, as well as 90-minute live calls where me and Melanie will be reviewing the material, and we're here and available for question and answer. And we've had some really good stimulating discussions in our previous cohort. So definitely consider checking that out if you've enjoyed this podcast. And also, I like to share that I have a YouTube channel and Instagram page called The Psychedelic Scientist, where I try to disseminate psychedelic research for a layperson audience as well. And I think just like Melanie, I'm very passionate about spreading quality information on the science in a way that's faithful to the actual findings, but also accessible at the same time. And it's really important to get that scientific information out there that's not totally watered down and clickbaity, which a lot of stuff unfortunately is. And so if you're interested, check that out as well. And Melanie, is there anything you want to say to end us
Yeah, I
off?
just wanted to also add that we talked about the research that came out of Gull Dolan's lab around the different psychedelics impacting the critical period in adolescence of social reward learning. And we are going to interview her on this podcast in a few weeks and do a deeper dive into that also. So stay tuned for that. And thanks for tuning into this episode, and look forward to catching you all in the next one.
Cool. Thanks, Melanie, and thank you, everyone.